Okay, first what we're going to do is we're going to put in our function f of x equals x to the second power. Now, to be able to move this, we have to unlock the figure. So now what we can do is we can go down, left, and right, and you'll notice that the algebraic form of the equation changes along with it. Let's put this back. And so to answer our first question, what shape does it create? It creates the shape of a parabola. And then whenever you're moving it up or down, not the entire graph, the parabola itself, when you move it up or down, all it's changing is that number on the right, if you'll notice. It's not changing anything associated with the x, it's only changing what's associated with the y's. Now if we go left and right, notice that it's only changing things associated with the x values. Which is going to be inside our squared function here. Now what we're going to do next is we're going to change the equation. We're going to change this to 3x squared. Okay, so notice that it's back here to 0, 0 for its vertex. Whenever we change the a value, that's the number that's in front of the x squared term, or x squared's coefficient. Let's see what happens here. There's 3. There's 8. Notice it's getting very skinny. Now if I change this to a number that is closer to 0, let's say 0.3, notice it gets very wide. So basically what we're going to say is this changes the width of the parabola. Now, instead of changing it a little bit at a time, what we're going to do is we're going to create a slider. So instead of using a number here, we're going to change this to the letter A. Notice that it's an undefined variable. I'm going to delete this out of here. F of x equals A. Notice that it's saying to create a slider for that. There we go. So here's ax squared, where a is 1. Notice that as a gets very close to 0, it gets very wide. As it goes towards larger and larger numbers, it gets very, very skinny. Now, notice what happens when it's negative. It's going to flip over that x-axis with the same effect on those absolute values. Now what we're going to do is we're going to create a slider for this second part here. So for B, what we want to do is create a slider. Let's see. Let's try again. Delete these. Ax squared plus b. Okay, so what we're going to do is we're creating sliders for a and b. So we know that the a value changes the width of the parabola. We also know that the a value changes the direction of the parabola, whether it opens upward or if it opens downward. Now let's look at the b value. If the b value is 1, notice that the vertex is at 1. And as I go downward, the width is not changing, it's just changing where that vertex is on the y-axis there. So the b value is going to move it up or down. Okay, so the next few things that we're going to explore with are creating some points. Let's create a point P at 3, 2. You can name the point in the input area over here to the left where the algebra is seen, or you can go and rename the point by right-clicking on it and then renaming the point there. Capital P means it's a point. Lowercase are vectors. So you want to make sure that you have the correct thing. Now, what we're going to do next is we're going to look at not only the A and the B, but the value of C. So let's delete these sliders here, and we're going to create a new one here. F of x equals ax squared plus bx plus c. And we're going to create some sliders for my A and my B and my C. Then go to my move tool here. Let me get it where you can see it. We don't want to look at point P anymore, so we're going to turn that one off. And for this particular object, we're going to take a look and see what the value of C does. The value of C, it looks like it's not getting wider or skinnier. It's just moving it up. Now, the slider for B, it looks like it's kind of moving it down at a diagonal, doesn't it? So this value of B is slightly different than the ones that we had looked at before. So it must be a mixture of a couple of different values that we've already explored. So notice that as it gets negative, now we're going to go over to the positive side of our graph. A lot of students don't understand what that b value actually is, but with some exploration in GeoGebra, they could probably figure it out. Negative c values, and then here's positive c values. So there's some interesting things happening here. And then a, of course, that's just changing the same thing that it always has been. Now, where it would really get interesting is if you put it in vertex form and they could actually see what each value really does. Of course, we know what the value of b is in this particular situation, ax squared plus bx plus c. But for students to be able to figure that out, they're going to have to write down some notes to see what exactly happens when it is positive, when it is negative, when it is a fraction, when it is not a fraction. And what is it doing to this vertex? That's what your b and your c value affect. So there's lots of different things in GeoGebra that can help students to figure things out about the algebra of a parabola, which is sometimes difficult for them.